This lesson is going to start off with a review of how to use these balanced reactions to do multiple ratios, and then we're going to talk about something called limiting reactants, and that is something that you probably did not do in honors chemistry. I know I didn't do it, we didn't have time last year, so you need to pay close attention to that because you will see it several times throughout the year in various units and various problems that you'll have to be able to solve. So let's just start with a review of how to use these reactions. These coefficients, these big numbers that are in front of the compounds, these are the multiple ratios. So what that says is I have a 1 to 3 to 2 ratio of moles of these compounds. So it's not an amount. It doesn't mean that we have 1 mole of nitrogen or 3 moles of hydrogen. It means that if we start with 1 mole of nitrogen, we would need 3 moles of hydrogen to react completely with it. Or if we started with 3 moles of hydrogen, we could turn that into 2 moles of NH3. So we only use them for conversions. So notice this flow chart, you probably did this in honors chemistry. And the big part here is going from moles to moles. So notice that these are both moles, but they're different chemicals. And the only link between them, the only way to link the A side of that picture to the B side of that picture is through those coefficients, that balanced reaction. And usually you're not given moles to start with. So the first thing you have to do is turn it into moles. So if they give you liters, grams, or particles, you can use those conversion factors to get it to moles. Then you would use the balanced reaction to turn it into moles of something different. And then if they ask you for a unit that is not moles, you'll have to do one more calculation to get it into whatever unit they're asking. So sometimes you'll have as many as 4 sets of numbers on your fence, but it just depends on what the question is giving you and what they're asking you for. So you can't really memorize that it's going to be 4 because they might be asking you for moles, and in that case you would stop at 3. So make sure when you're doing these problems, I'm not going to go into a lot of detail about this because we did it in our review unit, but you do need to practice some of this in those practice problems. What I want to focus on for today is called limiting reactants. So when you mix 2 chemicals together, most of the time one of those chemicals will run out before the other one, and we call that the limiting reactant. So here's the idea. If you want to make a cheeseburger, you have to have 2 buns, 1 burger, and 1 piece of cheese. That's the definition of what makes it a cheeseburger. So let's say that you have 8 buns, 3 burgers, and 2 pieces of cheese. How many burgers can you make? So what you're probably going to do to solve this problem is to take each of those numbers and turn them into cheeseburgers. So you say, okay, if I had 8 buns, how many cheeseburgers could I make? I could make 4 because it takes 2 buns per cheeseburger. If I have 3 burgers, how many can I make? I could make 3 because I have 3 pieces of meat. And if I have 2 pieces of cheese, I can make 2. Then what you're going to do is say, even though I had enough buns to make 4 cheeseburgers, I only had enough pieces of cheese to make 2. And therefore, that's how many I make. So after you turn them all into your product, you chose the smallest of the 3. You didn't add them all up together to get 9. You can't make 9 cheeseburgers from that. It's kind of like the weakest link. You're going to choose the lowest number that you have. So the answer there was 2. This section right here is really important for AP Chemistry multiple choice questions. A lot of times they'll ask you the idea behind limiting reactants and not just to solve them. So first of all, the limiting reactant is the one that gets completely used up in the reaction, so the one that you run out of first, and it limits the amount of product that can be formed. And what that means is once you use up the limiting reactant, the reaction stops. So you've made as much product as you can. And that's why they say when you're on fire, if your clothes are on fire, you probably learned at a very young age the phrase stop, drop, and roll, because what that does is it smothers out the oxygen so that you have no more oxygen, and then the fire can't burn because part of combustion, one of the reactants, is oxygen. So it becomes the limiting reactant. So again, number 2, the limiting reactant gets used up, and number 3, it determines how much product is formed. So make sure you understand all of those ideas about limiting reactant and not just how to solve it. All right, now let's talk about how to solve it. So the way that you know this is a limiting reactant problem, they usually are not going to say in AP Chemistry, this is a limiting reactant problem. You have to recognize when you see one. And the way you recognize it is because they'll give you 2 different amounts of different chemicals and ask you how much is produced. And you're like, well, how do we know which one to use? That's your clue that it's going to be a limiting reactant problem. So what you're going to do is exactly what we did with the cheeseburgers. You're going to take each of the amounts that they give you and turn it into product using this big chart up here. So if they give you grams of A, you're going to turn it into grams of B. If they give you grams of C, you turn it also into grams of B. So you turn everything into the same product. So turn them all into the same thing, and then you can compare them and choose the smallest amount. So again, it's kind of like the weakest link, because once you have the smallest amount, that's the most that you can make. From that smallest amount, the reactant that produced it is called the limiting reactant. A lot of times people don't quite understand these concepts, and for example, in the cheeseburger problem, they'll tell me that the limiting reactant is 2. That's not what the question is asking. The limiting reactant is the thing that you ran out of first, so the limiting reactant is the cheese. So it's the name of the chemical that you ran out of first. 2 is how much of the product that was formed. Let's go through an example and let me show you with some chemistry. So if you look at this example up here, it says the following reaction occurs. You're reacting 2 different amounts. So again, I'm having trouble zooming in. Okay, so this amount and this amount is your clue that that is a limiting reactant problem. They might not say it in the question. You know this one is because it's saying what is the limiting reactant. But when you're given 2 different amounts of 2 different things, that's how you know. So the first thing is to notice that we started with grams. Let me just go through the first fence with you. I use the periodic table to turn it into moles. And notice that all 3 of those are NH3, the first 3 fences. Then right here at this step right here, this is the step that allows you to convert into a product, because they want to know how much NO is produced. And so we use the mole to mole ratio. Those 4s came from the balanced reaction, came from right here and right here. And we can use those to convert into moles of NO, and then we turned it into grams because the question said what is the mass. So if they had just said which one produces more NO, we could have just left it as moles because moles is an amount, but they wanted to know the grams, so we went ahead and turned it into grams. So what that means is that if we have 17.6 grams of NH3, the most NO we can possibly make is 31 grams. And now that's assuming that we have infinity of the other reactant. So if we have as much oxygen as we possibly want, the most NO we can make is 31 grams. Then we're going to do it again. So notice the second time we're going to start with the oxygen and we're going to turn that into NO. So what that means is that if we start with 26.2 grams of oxygen and we have as much NH3 as we want, the most NO we can make is 19.6 grams, and at that point we run out of oxygen. So what this means is when we mix these 2 amounts, 17.6 grams of NH3 and 26.2 grams of O2, even though, this is important right here, even though we had enough NH3 to produce 31 grams of NO, we only had enough oxygen to produce 19.6 grams. So therefore, this is the most that can be formed, because once we make that much, we run out of oxygen, even though we had extra NH3. So now we know a few things. So first of all, you're always going to choose the smallest amount. Do not add those up together. For some reason, a lot of people do that. Also, be careful when you're turning them into products and make sure that you're turning them into the same thing. You can't compare them if you turn them into different things. So I see a lot of students that will set one fence up and turn it into NO, and then you see how in the reaction there's also some water. They'll turn the other one into water, and then they'll try to compare them, but you can't compare apples to oranges. They have to be the same chemical to compare them. So make sure you're turning them into the same amount. And so we have our smallest amount. We now know the limiting reactant. What you're going to do is take the smallest amount and go all the way back to the beginning of that, and that is your limiting reactant. And again, it's a name of a chemical. It's not an amount. It's the name of whatever you ran out of first. The other one is your excess reactant because you did not use all of that up. Excess means you have leftovers. All right, and then the last part of this question says we want to know how much of the NH3 was left. So now what we're going to do is start with the amount of product that we know was formed. So we know that we formed 19.6 grams of NO. So we want to see how much of the NH3 did it take to form that. We know it didn't take all 17.6 grams because we know it was excess, but we want to see how much it took. So again, turn it into moles, use the mole to mole ratio, turn it back into grams, and now we can see that it took 11.1 grams of NH3 to make that product. Well, we started with 17.6 grams, We used up 11.1 grams to make the NO, which means now we have this in excess. So use that as a guide as you're going through some of these problems to help you understand what steps to do next. But it's not enough just to memorize what to do next. I kind of want you to understand more than that and kind of understand the process for why you're doing what you're doing to make sure you understand the theory of these calculations. All right, a few more things. Percent yield is a way that scientists show accuracy. So it's kind of like it's actually the opposite of percent error. So you learn percent error in honors chemistry. This is just a different way to show it. So actual yield is how much you got. Theoretical is how much you were supposed to get. So your percent yield is what percent of what you were supposed to get that you actually got. And the good news is it's actually the same thing as your grades. So like when you get an 80% on the test, that's kind of like your percent yield. It means 80% of it you understood and 20% of it you didn't. So percent yield is showing what you did get. Percent error, what you did in honors chemistry, that is showing how much you messed up. So in that example, you would have a 20% error if you have an 80% yield. And they'll add up to 100 too. So they're, like I said, they're just opposite ways to look at it. All right, and the last things for these chapter are some more calculations that we did in our review unit, but we're going to keep harping on these because if you don't have these skills going into some of the college level problems that we're going to do, it's going to make it really hard for you. So I want you to feel really good about these. So the first thing is to understand your vocab. So molarity is the unit, concentration is the thing. So they might say one or the other. They won't say both. They might say what is the concentration of something, or they might say what is the molarity of something. So you have to know that those are interchangeable. One is the unit and one is the thing. For the units, you do need to have moles per liter. You can also use capital M, but that's basically what the equation is moles per liter. So it's a ratio. So of these three, they'll give you 2 out of these 3, but be careful, they might not give you moles, they might give you grams, and be careful here, they might give you milliliters. So be sure to convert back and forth if you need to. You can use the periodic table to go grams to moles if you need to. And our very last thing for chapter 3 and our last thing for unit 1 is dilutions. So again, here's your equation, M1V1 equals M2V2. And we're going to do a whole lot with dilutions where you're going to see some simulations about how to actually dilute something in the future. So for now, just see if you can understand how to use that equation. And the way you know to use this one, first of all, a lot of times they'll say dilute in the question. But also notice that you'll be given a couple of different molarities and maybe one volume or something like that. All right, make sure you practice some of these, especially these limiting reactant problems. They can be kind of tough at first, so once you go through a few of them, you kind of get the hang of what to do, but do be sure that you're practicing some of these and check your answers in the back of the book, and we will go over them in class as well. Thank you.